Corporate finance practice problem with OneNote. Present value of an annuity. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're going to be in the icon on the left-hand side in the practice problems area and down here in the 926 present value of an annuity. Also note, if using OneNote, that you might want to take a look at the immersive reader feature. Many of the presentations that we will have will then be mirrored down here in the text area. The text area will in essence be the transcripts. The transcripts can then be translated into Spanish, and you can actually hear them and or read them in multiple languages with the use of the immersive reader tool. So check that out if it sounds interesting. I'm going to close this back up. Here's going to be our information up top. We're going to do the calculation a few different ways. We're going to do it with a present value mathematical type of calculation. We'll then break down the annuity into present value of one calculations. Really useful skill to have, and it's really necessary once you get into more complex type of scenarios. So we will practice that again. And then we have the present value using Excel formulas, the easy way to get there. And then we'll do the present value with the use of the tables. So we're going to be running another kind of scenario here with our present values. This time we're going to say that we're going to receive, imagining this like if we won a prize, like a lottery or something like that, and they say you're going to be receiving so much money, and then in the fine print you see that it's going to be in the format of an annuity, which is kind of deceiving, almost dishonest. But you'd say, okay, what if the prize, how much would we get? Here we would say if we were getting 40,000 for 14 years, 40,000 times 14. So the prize might say that someone won 560,000 in a lottery or something like that in this type of scenario. And then you'd have to say, well, wait a sec, in the fine print it says, yeah, but you don't get paid that in one lump sum today. We're going to basically give it to you in $40,000 amounts yearly. Again, that's still good. I wouldn't complain or anything about it, but it's still a little deceiving because they're saying that they won 560,000. That's not really true, because in present value dollars, that's not how much you would get. So similar scenario with an annuity as to what if we were going to put in $40,000 into, say, an investment account, where would we be at the end? What would be the value of the investment situation? In other words, we could think of the present value of a series of payments we might put in and how much that would be equivalent as if we were to put in, the same dollar amount basically at this point in time. In order to do the annuity type of calculation, we do need a standard amount of payments here. So the standard payment being the 40, that allows us to, instead of doing 14 present value calculations, to do basically an annuity calculation, given we have uniformity in the payments as well as the percentage here. Now, if we do not have uniformity at some more complex scenario, then we can, of course, do some type of combination between present value of an annuity and present value of one. We'll take a look at that when we get down to the second component of this, when we do basically break this down into multiple present value of one type of calculations. So here we go. We're going to break this down into a formula, mathematical first. We got the formula of P times 1 minus 1 plus R to the negative N over R. That's going to be our calculation. We're going to break this down into basically a table type of calculation, useful to be able to put an equation into a table. In the outer column, we're going to want to then have the P times this whole thing. And then in this inner column, we're going to want to have the numerator and denominator broken out. And then in this inner column over here, we're going to further break out the numerator, given there's a lot going on with it. So we're going to say the payment is going to be the 40,000. And then we're going to say that we're going to pick up the 1, now going into the numerator, minus, and then I'm going to break out this other kind of component into its own category, 1 plus R to the negative N. So then we're going to have in the inner column here, 1 plus R, which is 14%. And if we add them up, then 1 plus 14%, I'm going to pull up the trusty calculator. Be careful of the decimals and percentages. So 1 we could represent as just 1 plus 0.14 would be 1.14 or 1.1 or 114%, whichever way we want to present that. And then we got to take it to the negative N, which is 14. This is the number of periods. We got to do a different calculator here, I believe, to be able to take it to that power. Let's change in our calculator in Windows to a scientific calculator. We're going to calculate scientifically here. So then I'm going to take this 1.14 and then we can take this to the power of, which is the caret up top, 14, and I need to make it a negative, so I'm going to hit this little item down here to make it a negative, and then calculate that. We get about the 0.159709, so on and so forth. So there we have that. If we subtract that from 1 then, because now we're up top here, so now we're going to take this 1 minus that. That'll give us the full numerator. We've finally got to the numerator once we do this. So I'm going to take that minus 1, and that's going to give us the 0.84029 and so on. It's not negative because it's really 1 minus that number. And there we have that number. And then we're going to pull in the denominator here. So now we got the numerator pulling in the denominator, which is or 14%. So then we can take this number. It's negative here, but it's a positive number, note, for our purposes. And we're going to say divided by the 0.14. That's going to give us about 6.00207 and so on, which I'm going to pull outside here. So now that's outside. So now we got our 40,000 times this whole thing that we've now calculated. So 40,000 where we started times this whole thing. So I'm going to take that whole thing. It's negative, but just note that it's, you know, it's going to be a positive number times 40,000. 40,000, and there's our 240082.86 about, and so that's what we have. So we had our 40,000 payments. Remember, if we were just to think about the amount of the payments, I'm going to bring this back on over to our normal calculator and make it smaller. If we had just the normal payments, we would have the 40,000, but we're going to get them over 14 years, would be 560, compared to if I was to present value the annuity, the 240,082.86 is what we would have for the present value of it. So then if I go back on down, we're going to say, and also just realize that if you have an option of taking the current amount or taking some amount in the future, then that would be one of the calculations you would have to think about. One of the varying factors, of course, being the 14%. You're going to have to come up to an appropriate percent, which is going to be some type of estimate to think about what that percent should be. So present value of an annuity. So now we're going to say that let's look at that in terms of breaking the annuity down into single present value type of calculations. This is something that you can do in Excel. Highly recommend doing it in Excel. We do have this practice problem in Excel for you to work it there as well. Now, the reason this is really useful to do is because this is, you should be able to see that when we break down an annuity to a present value of each period, 14 periods of present value calculations, then once we get to something that's more complex, not uniform, we have something that varies, in other words, between the payments that are happening and the percentages possibly, then we can use some combination of present value of one calculations and present value of annuity calculations to maximize whatever we're doing, for us to see it as simply as possible and for us to explain it as simply as possible to somebody else. So we'll break this down here to 14 present value of one calculations, which would look something like this. If this first 40,000 was going to happen in a year or something like that, we would have to bring the 40,000 back to the current time period. So we're taking this one payment, not 14 years out, but the one that's happening 1 year out, and bringing it back with a present value formula. Not present value of an annuity, present value of one. When we add up all those present value of ones, then it'll add up to basically the same thing that you would get with the present value of an annuity, given the fact that we have standard payments and percentages. So if we brought this one back, I won't do the calculation here, but we assume we just do it in Excel, and it's a present value calculation. Then we're going to say that we start off with the 35,087.72. If we have the second payment that happens after the second year, now we're going to do a present value calculation, this time not for period 1, not for 14 periods, but for 2 periods, because this is the period 2 calculation, bringing the 40,000 back to the present. Of course, the present value then being something different, something lower than the first payment in terms of today's dollars. And then if we take the 35,087.72 plus the 30,779 about, that's rounded, we get the 65,866.42. Then if we did this again, we got the present value of the third payment, another 40,000, present value calculation of that 40,000, this time using the number of periods of 3 as opposed to 2, 1, or 14, as we did before. And that then gives us another present value slightly lower or lower than the prior 2, because of course that 40,000 will be received further into the future, therefore further discounted. So the 26,999 added to the 65,866.42 gives us the 92,865.28, and so on and so forth. And then if we get down to the bottom of this, if we were to add this whole thing up, we get down to, once again, the 240.82.86, which matches up to the 240.82.86 up top. So note, if you look at this, it looks a little bit complex, but it does give us a lot more detail as to what is happening from period to period. And once again, realize that if you have something different with regards to the standardization or less than standardized payments for a certain period of time, for example, within this 14-year time period, maybe you're getting uneven, payments, more in one period than another. So you might have to use the present value of an annuity maybe for 4 years, and then the payment changes or something like that for a more complex payment situation, or the percentage changes in some degree. Then you might have to say, well, so many years out, I think the appropriate rate to be using would not be 14, but some other rate. Then once again, you might say, well, whenever it's standardized, if it were standardized, for example, for 4 time periods, then I can use an annuity for those 4 time periods and then possibly use present value of 1 or some other annuity calculation for the future periods. So realize that you can always break it down, in other words, basically to a present value of 1 type of calculation. But if you have a really long scenario of what is going on, then you might want to then use the present value of an annuity for the portions that you can, the portions that are uniform for presentation purposes and just so you can better understand it, and then break out whatever you need to break out with the present value of 1 calculations. So that's going to be that useful tool to have. And then if you're going to break this out or record this just with a calculation, a function in Excel, which you could do similar to a financial type of calculator, then you can have something like this. We'll just list it here. We do this in Excel too, so you can take a look at that as well. So it would be a present value calculation. The rate would then be the 14%. This is a yearly rate. If it was a monthly type of calculation, take into consideration, you would have to divide that by 12, comma, number of periods is going to be, in this case, 14. Once again, these periods being in terms of years for our problem here, comma, and then the payment, because it is an annuity, we have a payment being the 40,000. If it were not an annuity, present value of 1 calculation, we would use this same thing, but instead of having a payment, that payment would then be 0 or just 2 commas, and we would then utilize the future value. Considering it is an annuity, we don't utilize the future value and simply put the payment amount of the 40,000. That then, again, gets us to the 240,082.86. Yes. Then we have the table down below. One more time on the table, we can look this up on the table and do the similar type of calculation. We've got the 14 and the 14. That makes it easy. 14 and 14, I can remember that. 14% down to the 14 periods, 6.0021. So there's the 6.0021. The 40,000 times 6.0021 is 240,084, close to, but not exact to the 240,082.86 due to the fact that it's only rounded out 4 digits. If you wanted to see the entire number, we calculated it up here. It would be the 6.0020715003, but it rounded it down to 6.002, resulting in a slight difference. 1 probably would not affect your decision makings for most normal decisions, but 1 test questions could utilize to force you to pick one answer or another with a multiple choice question, for example, and force you to use one method or another. So note that these 2 methods down here, probably this method up top would be most used in practice, but it's kind of a magical method, and it would be useful, again, in those, if you have a more complex type of scenario, you could see where you might be able to use a present value type of calculation here in Excel and combine that with present value of 1 calculations if you had something that was less standardized for certain parts of the scenario, meaning less standardized in terms of the whole 14 years with regards to the payment amount or the percentage amount and or the percentage amounts.